right, these are the examples off the worksheet that we did together in class. Again, I probably told you when I sent out this video to skip through it and get to what we hadn't done in class. So just skip through, if you've already done some of it, skip through the video and find the parts that you need. The examples, this is for problems 1 through 6 on the skills practice 3-2. That's just that one worksheet that you picked up in class, the one that was hole punched that you can put in your notes. On this one, I'm going to go through and I'm going to do this. They tell us that these two lines are parallel to each other. Once I fill in this whole picture, then you can fill in the answers over for 1 through 6 and put in the correct answers for each one. They tell us angle 2 is 70 degrees, so I'm just going to write that in there. Well, if angle 2 is 70 degrees, and I'm going to use a whole bunch of different rules, just jumping around all over the place. You can figure out the angles. There's a million different ways to figure out the angles. You figure them out however you want to figure them out, whatever helps you. Like here, I know that angle 2 and angle 7 are alternate exterior angles, so I know angle 7's got to be 70 degrees. So I'm going to fill that in. I know angle 7 and angle 6 are vertical angles. So if angle 7 is 70 degrees, angle 6 has to be 70 degrees. Angle 3 and angle 6, if I trace them, they form that Z. Those are alternate interior, so they have to be congruent if these lines are parallel. So angle 3 has to be 70 degrees. I also know that let's say angle 6 and angle 4, they're the roommates. So they have to be supplementary. They have to add up to 180. So I can do 180 minus 70, which is 110. So angle 4 has to be 110 degrees. Ignore that. Angle 4 and angle 8, if I smash this line down on top of this line, angle 4 and angle 8 lay on top of each other. So they are corresponding angles, so they have to be the same. So that's 110. Angles 1 and 4 are vertical angles, so they have to be the same. So angle 1 has to be 110. Angle 1 and angle 5 are corresponding angles. So again, if these lines are parallel, if I smash them down on top of each other, 1 and 5 lay on top of each other. So angle 5 has to be 110. And now I found every angle in that picture. And now all you have to do is go back and answer the question. So if I go back to like number 1, and I'm going to do this for this problem, and then I won't do it for the rest of them. You can fill in the answers. If I go back for number 1, it asks you what's the measure of angle 3. So the answer to number 1 is just 70 degrees. And then number 2, they ask you for the measure of angle 5. Well, angle 5 is right here. That's 110 degrees, so the answer to number 2 is 110. So on and so on. You can just fill in the rest of the answers there on your own. This is for 7 through 12. On that same worksheet, on the front of that worksheet, they tell us angle 7 is 100 degrees. And again, I'm not going to fill in all the answers. We'll fill in all the numbers on the picture here, and then you can transfer them back to answer questions 7 through 12. When I'm looking at this, I know that M is our transversal. So this is our transversal going up through there. And I can separate it off however I want. If I get rid of line S and just look at the parts over here on the right hand side, look at line T, line U, and use M. Here's our transversal. I can find all these angles. If I know angle 7 is 100 degrees, angle 7, angle 9 are alternate interior angles. They form at Z, so they have to be congruent. So angle 9 is 100 degrees. Angle 7 and angle 11, if I smash the two lines together, those are corresponding angles, so they have to be congruent, so that's 100 degrees. Again, there's many, many different ways you could find all these angles. I'm just doing it this way. Angle 7 and angle 12 are consecutive interior angles, so they have to be supplementary. So angle 12 and angle 7 have to add up to 180, so that's 80 degrees. Angle 12 and angle 10 are vertical angles, so they have to be congruent, so that's 80 degrees. Angle 10 and angle 6 are corresponding angles. If I take this line and smash it on top of that line, they're going to lay on top of each other, so angle 6 has to be 80 degrees. Angle 6 and angle 5 are a linear pair, so they have to add up to 180, so that's got to be 100 degrees. Angle 8 and angle 6 are vertical angles, so they have to be the same, so that's 80 degrees. I found all those angles. Now if I jump over here and just use this part of the picture, I know that angle 8 and angle 2 are alternate interior angles, so they have to be the same, so that's 80 degrees. Angle 5 and angle 3 are alternate interior, so they have to be the same, so that's 100 degrees. Angle 3 and angle 4 are linear pairs, so they have to add up to 180. They have to be supplementary, so that's 80. Angle 4 and angle 1 are a linear pair, so they have to be supplementary, so that angle 1 has to be 100 degrees. Many, many different ways you can find each of these angles. I'm just making up stuff as I go to find each one of them. Then you go back and you answer the questions. Like if I go back and answer question 7, they say angle 9. What's angle 9? Well, angle 9 is right here, so the answer number 7 is 100 degrees. And then you can fill in 8, 9, 10, 11, 12 for that. If I go too fast or anything, then just stop the video. And again, you can skip through the video, skip stuff you don't need, whatever. Just run through it and do whatever you need to do. All right, the next one, they tell us angle 3 is 75 degrees, so I'm going to write that in here. That's 75 degrees right there. And they tell us that angle 10 is 115 degrees, so that's right there. And it says find the measure of each angle. I'm going to go through and I'm going to find all the angles on this picture. We don't actually need them all to answer the 6 questions about the picture, but I'm going to find them all, then you can answer the questions according to what we find. With this, you got to know that they tell you that Y and Z are parallel, but they don't tell you that W and X are parallel, so they're not parallel. So what we have to do is we have to separate this. We have to sort of split it off. If I'm going to use Y and Z, and then I want to use, let's say, W as our transversal first. So I'm just looking at this part of the picture, not looking at the bottom half of that picture. So if I know angle 3 is 75, angle 8 has to be 75 because they're vertical angles. Angle 8 and angle 1 are alternate exterior angles, so they have to be congruent, so angle 1 has to be 75. Angle 1 and angle 2 have to add up to 180, so 180 minus 75 gives us 105. Angle 2 and angle 7 are alternate interior angles, so angle 7 has to be 105. Angle 7 and angle 6 are consecutive interior angles, so they have to add up to 180, so angle 6 has to be 75. Angle 7 and angle 4 are vertical angles, so they have to be congruent, so that's 105. Angle 5 and angle 7 are corresponding angles. If you smash these two lines together, they're going to lay on top of each other, so angle 5 has to be 105. I found all those angles in that top part. Now what I'm going to do is I'm going to go back and I'm going to use Y and Z, those are our parallel lines, and I'm going to use X as our transversal. So I'm not looking at the top part, now I'm just looking at the bottom part. And again, it might help you if instead of doing it like I'm doing it here, you come over here and you separate off this way and fill in all the angles so that you don't get confused. Here I know angle 10 and angle 13 are vertical angles, so that has to be 115 degrees. Angle 10 and angle 14 are a linear pair, so 180 minus 115 That gives us 65, so that's right there. Angle 9 and 14 are vertical angles, so that has to be 65 degrees. 14 and 11 are alternate interior angles, so they have to be congruent, so that's 65 degrees. 10 and 15 are alternate interior angles, so they have to be congruent, so that's 115 degrees. Angle 14 and angle 16 are corresponding angles, so angle 16 has to be 65 degrees because they have to be congruent. Angle 10 and angle 12 are corresponding angles, so they have to be congruent, so that has to be 115 degrees. And I found all those angles on there, and again, if I look back and problem 13 says find angle 2, well, I just look up here and I know that the answer to that is 105 degrees, and then you fill in all the rest of the angles. Again, if I go too fast, just stop the video and look at the picture and fill in the angles as you need to. Number 19, they give us a picture, it looks like this. They tell us that these two lines are parallel to each other. This is our transversal. Many different equations you can set up on this. The first thing that catches my eye is these two angles right here. I know that those two angles together have to add up to be 180. So 5x plus 40 has to equal 180, and I'm going to solve that. Subtract 40 on both sides, those cancel out, you're left with 5x equals 140. Divide both sides by 5. You end up with x, grab your calculator if you need to, x equals 28. So that's part of our answer. They asked us for x. Now if I know that this angle is 40, something that might make it a little easier is once I know that angle is 40, instead of 5x right here, I know that this angle is 140. This angle and this angle are alternate exterior angles, and if these two lines are parallel, then they have to be congruent. So 3y minus 1 has to equal 140. I solve that, add 1 to both sides, I end up with 3y equals 141. Divide by 3, end up with y equals 3 will go into 4 times. That's 12, 21, 47. So x equals 28, y equals 47. And that's all they asked us to find on that was find x and y. Problem 20. They give us a picture, it looks like this. They tell us that these two lines are parallel. This is our transversal. This is 8x minus 10. And this is 7x. I'm going to stop right there before I write in the y stuff. Those two angles are alternate interior angles, so they have to be congruent. So 8x minus 10 has to equal 7x. Ignore that stray mark going up through there. I'm going to subtract 8x on both sides. These cancel out. You're left with negative 10 on the left. 7x minus 8x is negative 1x. To get x by itself, you divide both sides by negative 1. You end up with x equals 10. Once I know x equals 10, I can stick that back in for either one of these. 7 times 10 is 70. So I know that angle is 70 degrees. Well, I also know that that angle then has to be 70 degrees. And the other thing they tell us is that this angle is 6y plus 20. Well, these two angles are the roommates, so they have to add up to 180. So I can say 6y plus 20 plus the 70, these two add together, have to equal 180. Collect like terms here, 20 and 70 give me 90. Solve, subtract 90 on both sides, end up with 6y equals 90, ignore that. Divide both sides by 6, end up with y equals 90 divided by 6, grab your calculator, equals 15. So x equals 10, y equals 15. Problem 21, they say, a diagonal brace strengthens the wire fence and prevents it from sagging. The brace makes a 50-degree angle with the wire as shown. Find y. So if I'm looking at this picture, it's confusing looking at it that way. So I want to split it off so all I have are 2 wires and the brace. Well, the 2 wires that I want so that I can make the angles that I have in this, or that I need in this picture, are this wire and this wire. And then I'm going to use the brace as our transversal. So I'm just going to come over here and separate off those 2 and draw in the brace. I know that these 2 wires, hopefully if the fence is made correctly, are parallel. That right there is y. This angle out here is 50 degrees. If that's the case, then I'm looking at this and I notice that those 2 angles aren't really anything to each other. They're not corresponding, they're not alternate interior, not alternate exterior, not consecutive interior. But if I do this, if I know this is 50, I can find some other angles here, like this angle right below it. They have to add up to 180, so that angle has to be 130 degrees. If that angle is 130 degrees, that and the y are alternate interior angles, so they have to be the same. So that y angle there has to be 130 degrees. That's the answer they were looking for. Flip over to the back side of the page. Number 1 on the back side of the page, ask us to find the slope. We're just going to use the slope formula. Remember, slope, m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. With slope formula, not slope-intercept form, that's an actual equation of a line. We're just finding the slope. That's like part of the slope-intercept form. We need the y's on top. We're going to subtract the y's on top, subtract the x's on bottom. The points they give us, they tell us s is -1, 2, and they tell us w is 0, 4. This is an x, that's a y, this is an x, that's a y. Unlike with the midpoint or the distance formula that we did earlier, the order matters in this. All right, so it doesn't really matter which one you take first, but it matters that you do everything in the same order. So when I do this one, if I take this x first, then that means I got to take this y first, so on and so on. So for my y's, if I start here and go 2 minus 4, that's my y's. Remember, the y's got to be on top. Don't get them backwards. For slope, the y's have to be on top. If I started here, then that means I got to start with the -1 here. So -1 minus 0. 2 minus 4 is -2. -1 minus 0 is -1. We can reduce that down, and you could just reduce it down to 2. That would be your slope, and that's a fine answer. If you want to leave it as just 2 over 1, that's fine also, because remember, slope is rise over run. So this is telling us to go up 2 and to the right 1 each time. So that's our slope, either 2 or 2 over 1, either one of them is acceptable. Number 2, they give us these 2 points. I'm not going to write everything out completely every time. They give us -2, 5 is 1 point, and 1, -7 is the second point. We're trying to find the slope. This is an x, that's a y, that's an x, that's a y. It doesn't make any difference which order you go in, whether you start here and go to here, or start here and go this direction. Do what's going to make it easiest on you. All right, this time I'm going to start here, so 5 minus a -7. And then I do -2 minus 1 for my x's. The only reason I did it that way is because then I can change this to a plus. 5 plus 7 is 12. -2 minus 1 is -3. You can reduce that down. 3 will go into both of these. So if I divide the top by 3, I get 12 divided by 3 is 4. If I divide the bottom by 3, -3 divided by 3 is -1. That's my slope. 4, -1. 4 over -1. So that tells me to go up 4 and to the left 1 each time. Again, the more I do these, the less I'm going to write out. So when I do look at number 3, just looking at the paper there are y's. And I'm going to do this one backwards. I'm going to start with the point D. 3 minus 1. And our x's, 3 minus 0. The only reason I did that, make the math a little easier. 3 minus 1 is 2. 3 minus 0 is 3. That won't reduce any. So our slope is 2 over 3, or 2/3. Number 4. Again, it doesn't make it easier just going backwards or forwards, whichever. You got to look at the numbers and decide which way it's easier. This one, I'm going to start with J. And I'm going to go -2 minus a -4. Those are our y's. Our x's are -5 minus 5. Ignore that. Up on top, that's going to change to a plus. -2 plus 4 is 2. -5 minus 5. Grab your calculator if you need to and plug it in there. Don't just guess and think you got it right. -5 minus 5 is -10. And if I reduce that, 2 will go into 2 once. 2 will go into -10, -5 times. So our slope is 1 over -5, which means we go up 1 and to the left 5. All right, 5, 6, and 7, 5, 6, 7, and 8 use this. First thing they want us to do is to find the slope of line NP. All we're going to do to find that slope is count rise over run. So we just count up 1, 2, 3, 4, 5, 6. So we rise 6. And we go to the right 1, 2, 3, 4, 5, 6, 7, 8. So that goes on bottom. And we reduce that down. 2 will go into 6 3 times. 2 will go into 8 4 times. Our slope there is 3/4. If it's on a graph, you can just count rise over run. Up 6 over 8 to the right, we just reduce it down. Number 6 asks us to find the slope of line TW. And it doesn't matter which point you start at. I'm going to start at T. I go down 2, so that's a -2. And to the right 1, so that's a +1. You could reduce that down to just -2, or you could just leave it that way, -2 over 1. Number 7 says, find the slope of a line parallel to TW. Well, if 2 lines are parallel, remember in our notes, if lines are parallel, then that means the slopes are equal. So we want to find the slope of some line that's parallel to TW. So some line, I don't know, it might look something about like that. It's parallel to this line. Well, the slopes are going to be the same. So all we got to do is look here what the slope was of TW. It's just -2 over 1. That's our answer. And number 8 says the slope of a line. We want to find the slope of a line that's perpendicular to NP. So we want some line that hits NP and is perpendicular. So it hits it and it forms a right angle with it. So we want some line that looks like that. Well, if lines are perpendicular, then instead of their slopes being equal, their slopes are opposite reciprocals. Remember, opposite means you change the sign of it. So if it was positive, it becomes a negative. If negative, it becomes a positive. Reciprocal tells you to flip the fraction over. Well, if I go back up here, the original slope was 3/4. Ignore that. We want the opposite reciprocal of that. So that was a positive, so our answer is going to be a negative, and we just flip this over. So negative 4/3. You only put the negative, it could be written negative 4/3, it could be written 4/3, or it could be written negative 4/3. Any of those will work. Don't put a negative on both of them. It's just, so don't write negative 4/3. That's something completely different. It's a completely different answer, so that's our answer. One of those three. Nine, 10, 11, and 12, they're asking you if those lines are parallel, perpendicular, or neither. All you're going to do on this is you're going to find the slope of each one. If you wanted to graph them and find the slope by doing count and rise over run, that's fine. I'm going to do the slope by using the formula each time. And since we did this several times already, I'm going to go through it sort of quickly. So for line AB, remember it's y is on top, x is on bottom. So for A and B, I got 3 minus a negative 7. For my y's, for my x's, I got 0 minus 5. This changes to plus. That's 10 over negative 5, which reduces down to 2 over negative 1. For line MN, I've got my y's are 7 and negative 1. 7 minus a negative 1 over my x's are negative 6 minus a negative 2. That's going to change to plus. That's going to change to plus. 7 plus 1 is 8. Negative 6 plus 2 is negative 4. I reduce that down. 2 will go into 8 4 times. 4 will go into 8 2 times. I want the biggest number. 4 will go into 4 1 time, negative 1. I look at these two, and that tells me that these lines are parallel because they have the same slope. So that's my answer. Number 10, for line AB, the y's are 4 minus a negative 5, and the x's are negative 1 minus 2. That's going to change to plus. That's 9. Negative 1 minus 2. Again, grab your calculator if you're not sure. Ends up being a negative 3. 3 will go to 9. I reduce this down. 3 will go to 9 3 times. Ignore that. 3 will go to negative 3, negative 1 times. So that slope is negative 3 over 1. Slope of line NM. Same thing. Let's see here. It's our y's are 2 and 0, so 2 minus 0. Our x's are negative 3 minus a negative 1. Change that to plus. 2 minus 0 is 2. Negative 3 plus 1 is, hold on, did I write something wrong here? AB. Yep. Sorry, I looked at the wrong number, I think. See, our 2 minus 0 is our y's. Negative 3 minus 3 is our x's. I looked at the wrong thing there. 2 minus 0 is 2. Negative 3 minus 3 is negative 6. 2 will go into 2 once. 2 will go into negative 6, negative 3 times. We look at these two, compare them. They're not the same, so they're not parallel. The other thing is if they're opposite reciprocals, then they'd be perpendicular. Well, they're flipped over, but they're both negative, so they're not opposites of each other. So they're not perpendicular, so this one is neither. So that's the answer to that one, it's neither. Sorry about that, I looked at the wrong number. Number 11, for AB, line AB, our y's are, I'm going to go backwards this time, 2 minus a negative 7, and then 4 minus a negative 2. And again, I'm just going the other way because this time I noticed that that would end up doing that and make it a little easier on me, so that's 9 over 6. 3 will go into 9 3 times, 3 will go into 6 twice, so that reduces to 3 over 2. Let's see here for MN, line MN, our y's are 6 minus 0. Again, I'm going backwards, 2 minus 4. 6 minus 0 is 6. 2 minus 4 is negative 2. Do something wrong again. I wrote the wrong number down again. So let's see, for MN, the y's are 6 minus 0, then the x's are 2 minus a negative 2. I just wrote down the wrong number, keep looking at the wrong thing. That's going to change to plus. 2 plus 2 is 4. 2 will go into 6 3 times, 2 will go into 4 twice. We look at these two, they're the same, so that tells us that those two lines are parallel. Need to be wearing my glasses. Number 12, line AB, same setup. Our y's this time are negative 8, negative 6, so negative 8 minus a negative 6 over negative 4 minus 4. Change this to plus. That's negative 2 on top, negative 8 on bottom. I'm going to divide these. First, the negative divided by negative is going to be positive. 2 will go into 2 once. 2 will go into 8 4 times, so that's 1/4. Line MN. Let's see if I can do this one without reading the wrong thing here. Our y's are 5 and negative 3, so 5 minus a negative 3 on top. Our x's are negative 3 minus a negative 1. Change that to plus, change that to plus. Sorry, this is supposed to be a negative. We got 5 plus 3 is 8. Negative 3 plus 1 is negative 2. Reduce that down. 2 will go into 8 4 times. 2 will go into negative 2, negative 1 times. And I compare these two. Well, I look at them and one's negative, one's positive. They're reciprocals of each other. So that tells us that these two are perpendicular. They come together to form right angles. Next slide, they want us to graph each of these. I'm just going to draw my X and Y axes on here. My graph's big enough that I can probably just fit just about anything on it. First thing you're going to graph point A. Point A is 0, 1, so that tells me to go left or right 0 and up 1. Make sure you don't get that backwards. That's point A. Then from that, our slope, this is number 13, our slope is 3. Well, if it helps you, put a 1 underneath that. Remember, this is rise, overrun. The 3 tells us to go up 3. The 1 tells us to go to the right 1. So I just go back to this point A that I just graphed, and I use this to move. So I go up 3 to the right 1, up 3 to the right 1. If I run out of space going that way, and instead of going up and to the right, I can go down 3 and to the left 1. And then our line's going to look something like that. Number 14, this time they tell you to start at the point -4, 5. So I go 1, 2, 3, 4 to the left, up 1, 2, 3, 4, 5. That is point R. The slope this time, M equals -3/2. However you do this, you got to sort of take this negative and either put it on the 3 or put it on the 2. I'm going to put it on the 3, ignore that. I'm going to put it on the 3. So that's telling me to go down 3 and to the right 2. So I go back to this point that I was at, down 3, 1, 2, 3, to the right 2. Down 1, 2, 3, to the right 2. Down 1, 2, 3, to the right 2. Notice they all fall in one straight line there, one line. That's the line they wanted on number 14. Again, notice this line, it had a negative slope. So it should be a line that's going down from the left to the right. The last one had a positive slope, so it was going up from the left to the right. Number 15, a little tougher on number 15. They say it contains the point 30 and it's parallel to line DJ, and then they give you the points for line DJ. Well, if they're parallel, then we know that their slopes have to be the same. So what we have to do is we have to find the slope of line DJ. And we're just going to use that formula like we used on several of those other problems. So the Y's are 1 and 3, so I'm 1 minus 3 on top. And the X's are -3 and 3, so -3 minus 3 on bottom. 1 minus 3 is -2. -3 minus 3 is -6. I'm going to rewrite that down here. -2 over -6. Negative divided by negative is positive, so we can get rid of those. 2 will go into 2 once, 2 will go into 6 3 times, so our slope is 1/3. Since our lines are parallel, the slope that we want is 1/3. Now I'm going to come over here and graph the original point that they gave us. The original point they gave us, looking back at the problem, was y is 3, 0, so we go right 3 and up or down 0. That's y, ignore that. That's y. Then we use this slope to move. It tells us go up 1 and to the right 3. So I go up 1 to the right 3. Up 1 to the right 3. If I run out of space going that way, then I can go down 1 to the left 3. Down 1 to the left 3. And I missed our points there, but it should look something like that. This one had a positive slope, so again, it should be going up from the left to the right. That was number 15. This is number 16. Start off this time, I'll graph the point first here. They say that our point contains a point 0, -2, so I go left or right 0, down 2. That's point T. And we want a line that's perpendicular to CX. So line CX, we're going to have to find the slope of it. We'll use that formula again. The Y's are 3 minus a -1. The x's are 0 minus 2. Change that to plus. 3 plus 1 is 4. 0 minus 2 is -2. We can reduce that down. 2 will go into 4 twice. 2 will go into -2, -1. So that's the slope of line CX. But we don't want the slope of line CX. We want the slope of a line perpendicular to it, which means we want the opposite reciprocal. So the slope that we want, we flip this over and we change the sign. So we flip it over, and that becomes 1/2, and this was a negative, so now it's a positive. So we have the slope is 1, 2, that tells us go up 1 and to the right 2. So we start here and we go up 1 to the right 2, up 1 to the right 2, up 1 to the right 2, up 1 to the right 2. And our line's going to look something like that. It had a positive slope, so it should be going up. On the packet, look at the first page of the packet. First couple are just finding the slope. So on those, to find the slope of that line BR, and I'm not going to do every one of these because we've already done this several times for some of these. A lot of these are the same as what we just did. So I'm going to skip to some of the other problems here in a minute. The slope for BR, we subtract the y's on top. So 4 minus 2. Subtract the x's on bottom, so -4 minus 0. 2 on top, -4 on bottom. We can reduce that down to, oops, not 2. We can reduce that down to 1 over -2, so that's the slope of that first one. Bunch of the rest of those on that first page are just the same thing that we were doing, so you should be able to handle those. The second page at the top, it's just graphing those lines again. We just got done doing some of that. Jump to problem 24 on the second page. Problem 24 says, write an equation in slope-intercept form of the line having the given slope and y-intercept. So they tell us that m is -4, the y-intercept is 3. Well, all we need to know to write an equation is either the slope and the y-intercept, and we can write it in that y equals mx plus b form. So we're going to put m in place there, b in place there, and that's going to be our equation. Or we can write it in point slope form, which looks like this. And to write it in that form, we need a point and the slope. The two coordinates of the points are going to go in here for y and x, and then the slope's going to go in there. This time they tell us the slope and the y-intercept, so this is the easiest form to write it in. Y equals mx plus b. In place of m right here, we're going to stick in -4. So y equals -4x. In place of b, we're going to stick in 3. That's our equation. That's all you had to do on that one. 25 is the same kind of idea. Y equals mx plus b. They tell us m, this time is 3. So in place of m, I'm going to stick in 3. In place of b, they tell us it's a -8, so you just put -8. That's our equation on 25. Twenty-six, they give you m equals 3/7, and they give us this point 0, 1. Anytime they give you a point and the x coordinate is 0, that number right there, that y coordinate, that is your b, that is your y-intercept. So to write our equation, y equals mx plus b, all I'm going to do is I'm going to put in place of m 3/7. The x stays there. And in place of b, I'm going to stick in that number right there, which is just 1, so plus 1. That's our equation. 27, if you look at it, same idea, so I'm going to do it real quickly. Y equals, the slope this time is -2/5. So y equals -2/5 times x, and the y-intercept is -6, so -6. That's our equation. (28), (29), (30), and 31 a little different. I'm going to do it. I'm going to do them. The first one I'll do a couple different ways, and you can pick out which way you want to do the rest of them. This time they tell us for this one the slope is 2, and they give us some point, 5, 2. Well, this time the x here is not 0, so this isn't our y-intercept. I like doing it using slope or point slope form. But a lot of students don't, and I'll show you another way that you can do it not using point slope form. And it's up to you whichever way you write the equation. So using point slope form looks like this. This is our x1, this is our y1, this is our m. And all we're going to do is plug in those three things. Y minus, our y1 is 2, our m is right here is 2, our x1 is 5. Notice that these are always minuses. Unless you stick in a negative, then it's going to change to a plus. Now that's in point slope form. That's an equation, and that could be our answer if that's the form we wanted it in. If they want it in slope intercept form, then you got to do 2 steps. Step 1 is you distribute. So we're just going to go here and we're going to distribute this out. So it ends up y minus 2 stays the same. 2 times x is 2x. 2 times the -5 is -10. Then step 2, we get y alone. And all I mean by that is you're going to move this -2 over to the other side. So we're going to add 2 to both sides. These cancel out. You're left with y equals 2x. -10 and +2 give us -8. Notice that now that equation is in slope intercept form. So we now know that the slope is 2, the y-intercept is -8. The other way that you can do it, instead of using point slope, is to just use slope intercept, but you have to find what b is, find what that y-intercept is. And the way that we can do that is by using slope intercept form, y equals mx plus b. Well, we just use this information that they give us, and we stick in for x, we stick in for y, and we stick in for m. So y, if we look right here, is 2, so we just take that and stick that in there. M is right here, so we stick 2 in its place. And x is right here, that's 5, we stick it in place of x. And all that leaves us with that we don't know is b. And then we do a little math here to find b. 2 times 5 is 10. And we subtract 10 on both sides. These cancel out and you're left with just b. We're just solving for b here. 2 minus 10 is -8. So now we know the y-intercept is -8. And we know the slope, they told us, was 2. So we take that y equals mx plus b form again. In place of m, we stick in the slope. In place of b, we stick in the y-intercept. In place of m, we stick in 2, because that's what they told us. X stays the same now. And in place of b, we stick in our y-intercept, which is -8, so just -8. That's the equation of our line. And if you'll notice, whichever way you do it, they come out the same. I don't care which way you write the equation, There's two different ways there. Number 29, same idea. This time they tell us m is -3, and they tell us the point that we have is 2, -4. I'll do another one using the point slope and finding the b. I'm going to shorten this up a little bit. Again, this is our x1, this is our y1, this is our m. So just doing this y minus, this time it's a -4. So it's y minus a -4 equals, our m is -3. X minus our x1 here is 2. This I'm going to change to plus. So it'd just be y plus 4 equals -3 times x minus 2. That's in point slope form. Then I'm going to get it in slope intercept form, so I'm going to distribute here. Y plus 4 equals -3x. That's supposed to be a -2 there, so -3 times -2 is a +6. Then to get y by itself, I'm going to subtract 4 on both sides. Those cancel out. Leave me with y equals -3x plus 2. That's our equation. Again, I don't care which way you do it. Just don't mix up the two ways and get them all, messed up. So if I'm using slope intercept form, I got y equals mx plus b. I'm going to plug in place of y, m, and x. Y is -4, m is -3, x comes from right here is 2, the b we don't know. -4 equals -3 times 2 is -6 plus b. Add 6 to both sides. End up with b equals 2. We already knew that m was -3. And I just go back to my y equals mx plus b form, and I plug in for m and I plug in for b. So y equals -3x and b is 2, so plus 2. That's our equation. And when I look at these two, they should come out the same equation here. You don't have to do both, just one or the other, whichever one you think is easiest for you. Number 30. It tells us the slope is -1/2 and the point is -2,5. I'm just going to do the b method for these last two. So to find b, we're going to use this as our x, this is our y, this is our m. So 5 equals -1/2 times -2 plus b. 5 equals -1/2 times the -2, that's going to be a positive. Half of 2 is just 1 plus b. Subtract 1 on both sides. Sometimes this form, or this way, it works out really easy. So b equals 4. M is -1/2 still. I'm going to plug into y equals mx plus b form. So y equals -1/2. That's our m times x. B is 4, so plus 4. That's our equation. They tell us the slope is 1/3, and the point this time is -3, -8. That's a -8. So if I use that same form again, this is our x, that's our y, this is our m. So y is -8 equals 1/3 times -3 plus b. Don't get scared just because there's fractions. When you multiply these two, You just multiply 1 times -3, that's -3. 3 times 1 is 3, so you got -3 over 3, which just reduces down to -1. So you got -8 equals -1 plus b. Add 1 to both sides. These cancel out, you're left with b equals -7. They told us that m was 1/3. We write our equation, y equals, our slope is 1/3 times x plus, or minus 7. That's our equation. All right, this next one uses this picture, and it says write an equation in slope-intercept form for each line. First one they give us is number 32, is line R. So we're looking at just line R, that's this line right here. We want to find the slope and the y-intercept. I usually find the y-intercept first because it's pretty easy. Wherever this line crosses the y-axis, that's 1, 2, 3. So b is just up 3, so it's a positive 3. Then the slope, you just find 2 points that fall on the line and find the slope. So rise over run. Well, if I have these 2 points, I go up 1, 2, 3, over 1, 2, 3, 3 over 3, which is just 1. So our equation is just going to be y equals the slope, which is 1, times x, plus the y-intercept, which is 3. That's our equation. That was for line R. Line T. Line T is this line. We want the slope and the y-intercept again, and usually I find the y-intercept first. The y-intercept, this time for line T, looks like it intersects the y-axis right here, so that's down 1, 2, 3, so that's a -3. The slope, just find 2 points and count rise over run. So 1, 2, 3 up, to the right 1, so 3 over 1, which is just 3. You can write it either way. Y equals just 3x, or you could put a 1 underneath that 3 if you wanted. And the y-intercept's -3, so -3. And 34 says we want the line, we want to write an equation for a line that contains the point 1, -1, and it's parallel to R. Well, if we go back up here, this one was R. If it's parallel to R, then that means the slope has to be the same, so the slope has to be 1. So if I come over here and I graph it, I go to the point 1, -1, go 1, -1, that's that point right there. And our slope is just 1, so we put 1 over 1, that means we go up 1 to the right 1, up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. Well, going up and to the right is not helping us find the y-intercept, so we could go down 1 to the left 1. Well, looky there, we hit the y-axis, so that's our y-intercept. That's the line that we're talking about. And that y-intercept then is -2. That means when we write our equation, it's going to be y equals 1x, that's our slope, minus 2. That's our equation. (35) says write an equation in slope-intercept form for each. These aren't too difficult. They tell us the slope is 6, the y-intercept's -2. So it's just going to be y equals, our slope is 6, so 6 times x, and our y-intercept's -2, so that's our equation. 36, they tell us that it goes through the point 0, -6. Well, if it's going through that point 0, -6, again, if the x is 0, then this right here is your b. That is your y-intercept. So when we write our equation, they tell us the slope is -1. So y equals -1x, and our y-intercept is -6, so -6. 37, they give us 2 points, 2, 0, and 0, 10. Well, the first thing we got to do then is we got to find the slope. So our y's are 0 and 10, so 0 minus 10. Our x's are 2 and 0, so 2 minus 0 on bottom. Ignore that, that's negative 10 on top, 2 on bottom. That reduces down to just negative 5, so that's our slope. Again, our y-intercept is that second point, 0, 10. So our b is just 10. So y equals our slope, which is negative 5 times x. And our y-intercept is positive 10. That's our equation. Problem 38. They say, write an equation for a line that passes through the given point and is parallel to the other line. That other line this time is y equals 4x minus 7. Again, to write an equation, we need the slope and the y-intercept of a line. So if I take, we know that our line, our new line, let's put that new. Our new line goes through the point negative 1, 3. And it has a slope that makes it parallel to this line. Well, the slope of this line is 4. Well, if the two lines are parallel, then the slopes are the same. So this line has to be 4. So now what we got to do is we got to take this information and write an equation. Don't make this any harder than it is. This same thing that we were doing on all the other problems. It's just now they're throwing in a little extra there and saying, okay, it's not this line, but it's parallel to that line. So we know our slope is this. We know a point that it goes through is this. We can use, again, we can find the b or we can use point slope form, either way. This time I'm going to use point slope form. So remember, point slope form is this. Doesn't matter. The rest of them I'll use finding the b if just that's what most people seem to like. This is my x, that's my y, x sub 1, y sub 1, that's my m. So I'm just going to stick those in there. Y minus, our y sub 1 here is 3, our m is 4, our x sub 1 is negative 1. So when I put in minus a negative 1, ignore that. That's going to end up being plus there. So then I have this. I'm going to distribute, get rid of that. Y minus 4, or I'm sorry, y minus 3 equals 4x plus 4. Add 3 to both sides. End up with y equals 4x plus 7. That's our equation. Problem 39. Same idea, they give us a point and the slope. I'm not going to write everything down this time. We look at that line that they gave us. They gave us y equals negative 6x plus 10. Well, that negative 6 is our slope, and we want a line parallel to that. So the new slope has to be negative 6. To find b, I'm going to write b up here. To find b, if we want to find it the other way, I got y equals mx plus b. They tell us that it goes through the point 2, negative 3. So our x is 2, and our y is negative 3. We know our slope is negative 6, and we're looking for the b. Negative 3 equals negative 6 times 2 is negative 12 plus b. Add 12 to both sides. You end up with 9 equals b. So b equals 9. Now I'm just going to take that and put it in that y equals mx plus b form. Y equals negative 6x, that's our slope, plus the y-intercept, which is 9. That's our equation. Remember that this line is parallel to the line that they gave us. Number 40, this time they're saying instead of parallel, they want them to be perpendicular. If they're perpendicular, remember their slopes are opposite reciprocals. Opposite reciprocals. means you flip it over and you change the sign. So this time we look at number 40. The slope of the line that they give us in number 40 is -3. So that's the slope that they give us, -3. We don't want that slope. We want the opposite reciprocal of that. So the slope of our new line is going to be, you flip that number over and you take the opposite. So we flip it over and it becomes 1/3. This one was a negative, so we want it to be positive. So that's the slope of our new line. Then we got to find the b of our new line, and we do that the same way. Y equals mx plus b. They tell us that our new line goes through the point 6, 10. Well, x is 6, y is 10. So we just, in here we stick in 10 equals, the slope is 1/3. The x is 6. The b we don't know. Don't let this confuse you because it's got a fraction in it. 1/3 of 6, or if you just put a 1 underneath that, 1 times 6 is 6. 3 times 1 is 3, so you got 6/3. 6 divided by 3, which is just 2. So you got 10 equals 2 plus b. Again, you can plug all that into your calculator, and it'll do 1/3 times 6 for you. Subtract 2 on both sides, you end up with b equals 8. Then we just plug that into our slope-intercept form. Y equals, our slope is 1/3, our b is 8. That's our equation. 41, they made it a little easier on us because they gave us this point, 0, -8. Well, if that's -8 and this is 0, that is our y-intercept. So we know our b is -8. Now all we got to do is find our slope of this new line. The equation they gave us is y equals -1/3 x minus 10. This is the slope of their line. We want the opposite reciprocal of that. So we flip it over. And this one was a negative, so we want a positive. So our slope is just 3/1 or just 3. In our equation, y equals our slope times x. And then -8 is our y-intercept, so -8. That's our equation. Flipping over to the last page. 42. It's in Word, it's just in Word form, but it says the same kind of setup. Write an equation of a line passing through the point -1,3 that is perpendicular to y equals 4x minus 7. So y equals 4x minus 7. The slope of that is 4. That was a 4 before we want the opposite reciprocal of that for the slope of our new line. So 4/1, we have 4/1, we flip it over, and we take the opposite. It was a positive, now it's going to become a negative, and we flip it over so it's -1/4. That's the slope of the new line. And now we need to find b. We're going to do the same thing. They give us a point that it goes through, which is -1,3. Ignore that. This is x, that's y. So we plug in 3 equals our slope, which is -1/4 times 1 plus b. So we end up with 3 equals -1/4 times 1 is -1/4 plus b. We're going to add 1/4 to both sides. These cancel out, you're left with just b equals 3 plus 1/4 is just 3 1/4. So that's our b. When we write our equation, it's y equals -1/4 x, that's our slope, plus 3 1/4. I would accept this form. It's not a real great form. A better form when you're dealing with algebra is if you change this mixed number. We don't like mixed numbers in algebra. Change it to an improper fraction. The way you change that to an improper fraction, you multiply the whole number times the bottom, and then add that answer to the top. So 3 times 4, I'm going to write down the rest of this first. That's negative 1/4 x. 3 times 4 is 12, plus 1 is 13, and then the bottom number stays the same. So that's a little better form. So everything's just written as a fraction instead of that mixed number. 43, write an equation of line passing through the point that's parallel, so it goes through the point -1, -4, and it's parallel to y equals -6x plus 8. Well, the slope of this line is -6, so if they're parallel, the slope of our new line's got to be -6. And to find the b, we do the same thing. Y equals mx plus b. We're going to plug in for y, we're going to plug in for m, we're going to plug in for x. This is our x, that's our y, this is our m. So -4 equals -6 times x is -1 plus b. That's -4 equals 6 plus b. Subtract 6 on both sides. We end up with b equals -10. And we just take this information and write our equation. Y equals -6x minus 10. Problem 44. Your friend claims that if a line has a slope that is less than 1, then any line perpendicular to it must have a positive slope. Is your friend correct? Explain your reasoning. So they say that the slope's less than 1. Well, then that means the slope could be like -2. That's less than 1. If that's the case, then the opposite reciprocal of that would be we flip it over and change the sign. So then, yes, it would have to be positive. But a slope less than 1. Well, slope less than 1 could also be something like 1/5. That's less than 1. The opposite reciprocal of that would be if we flip it over, and this was a positive, change it to a negative, now that slope is negative. So this is a counter example. So is your friend correct? No. If m equals 1/5, then the perpendicular line would have slope of -5/1. So it's not positive. Forty-five is a little more challenging of a problem. Says a line that goes through 3, 5 and K12. So we don't know what K is and we're trying to find it. Is perpendicular to some other line that goes through 0, 7 and 2, 10. So what I can do there is I can find the slope of that second line. That means I'm going to subtract my y's on top, x's on bottom. So 10 minus 7, that's my y's. And then got to go the same direction, so 2 minus 0. Just did that to try to make it easier on myself. So that's the slope of the second line. We want a line that's perpendicular to that. So if it's going to be perpendicular to that, then the slope's got to be the opposite reciprocal, which means we flip this over and we change the sign. So -2/3. So that's the slope of our new line. Well, the slope of our new line, or of the line that has the K in it, we can do the equation for, And that's, let's see, we got our y's, which is 12 minus 5, and our x's, which is k, ignore that, minus 3. Well, that slope should equal this, so negative 2/3. And I'm just going to do a little math here. 12 minus 5 is 7. On bottom, we still got k minus 3. We can't really do a whole lot to that because we have that k in there. Negative 2 over 3. Several different ways that you could solve this. Probably the easiest way for students, I'm going to put parentheses around this, and then I'm going to solve it like a proportion. I'm going to cross multiply. So doing this way first, I get negative 2 parentheses k minus 3 equals, doing the other way, I get 7 times 3. Here I can distribute, that's negative 2k. Negative 2 times negative 3 is positive 6. On this side, 7 times 3 is 21. Subtract 6 on both sides. End up with negative 2 times k equals, that's 15. Divide both sides by negative 2. And I end up with k equals negative 7.5 or 7.5. So that's our k. K is negative 7.5. Not a pretty point having a half, but that's our answer. And number 46, see if I can fit this on here. Two lines are perpendicular. Is it possible for the lines to have the same y-intercept? Justify your answer. So if I'm on a graph, matter of fact, let's see if I can. So if I'm on this graph, and I got these two lines. That's my y, that's my x. I got two lines. Can they have the same y-intercept? So if I got some line that comes down through here and the y-intercept is right there, can they have the same y-intercept and be perpendicular? Well, all they're asking you is there some line that's going to go through this same point right here and be perpendicular to that. So yeah, there would be. So is it possible? The answer is yes. And just because they have the same y-intercept, that doesn't affect their slopes. So the y-intercept, ignore that, does not change the slopes. So as long as the slopes are opposite reciprocals of each other, like if I'm looking at this one, it looks like, on this one, it looks like I went up 1 over 1, up 1 to the left 1, sorry, so that's a negative 1 slope. Well, this one looks like I went up 1 to the right 1, so that's a positive 1 slope. Well, those are opposite reciprocals of each other. So yes, that's the case, and that would be our answer.